Hello friends, in this video we shall continue our discussion on concentrations. In our last video we discussed about molarity, normality and strength. So in this video we are going to discuss about molality. Okay. So by definition, molality equals number of moles of solute divided by mass of solution in kilogram. Okay, so here just remember that the mass of solution contains the mass of solute plus mass of solvent. So here this will be, molality is represented by small m. So small m will be number of moles of solute divided by mass of solute plus mass of solvent. Okay, so everything is in kilogram. Okay, so now if we simplify this expression, we shall get that m equals weight or mass into weight of solute divided by molecular weight of solute into weight of solute plus solvent. Okay. So this is in kilogram. So here molality becomes weight of solute upon molecular weight of solute into weight of solute plus solvent. Okay, so here now if we take number of moles of solute into consideration and then compare molality with molarity, then we will get, since we know that molarity equals number of moles of solute divided by volume of solution in liters. Okay, and small m, that is molality, equals number of moles of solute divided by weight of solution in kilogram. Okay, now if we equate number of moles of solute, then let's see what we should get. So here, equating the number of moles of solute, we will get molarity into volume equals molality into weight. Okay, so now if we rearrange this expression, we will get molarity equals molality into weight upon volume. So from here we can say that molarity equals molality into density. Here we get molarity of the solution equals molality of solution into the density of that particular solution. Okay, so let's discuss some question. The question says that 107 grams of NaCl is added in water. What volume of water must be taken to make a 3 molar solution? Okay. The question is that 107 grams of NaCl is added in water. What volume of water must be taken to make a 3 molar solution? Okay. So here you know that molality equals number of moles of solute divided by weight of volume in kilogram. Now here the density is given to be of water is given to be 1 kilogram per liter. Okay. So from here we can say that since density is 1 kilogram per liter, therefore V liter water equals V gram of water. So from here, if we substitute the expressions, we will get 3 equals number of moles of solute. Number of moles equals weight upon molecular weight. So the weight is 107 grams. Now molecular weight. Molecular weight here is 23 for NaCl. For NaCl, molecular weight equals 23 plus 35.5. This equals 58.5. So gram molecular weight in case of NaCl is 58.5. So we will write here 58.5 into. Now suppose V liter of water is taken. Therefore, V gram of water is taken. So here we will write V gram of water. Now the weight is that of solute plus solvent. So water is acting as solvent. So here V gram of solvent is taken. Now we will take 107 gram of solute also. So we have taken 107. Now this weight must be converted into kilogram, because in case of molality the weight should be taken in kilogram. So now let's convert this particular weight in grams into kilograms. So we'll have to divide it by 1000. So from here we get 3 equals, this will get cancelled. So 3 equals 2000 divided by V plus 107. So if we simplify it further, we will get 3V plus 321 equals 2000. So now let's simplify it. If we simplify it, we will get volume equals 2000 minus 321 divided by 3 grams. 3 grams. So here V milliliter. This is V milliliter will give V gram of water, because the density is 1 kilogram per liter. So the volume is 2000 minus 321 divided by 3. Okay. So the correct answer for water is V will be equal to 1679 divided by 3 gram of water, or weight of water taken equals 1679 divided by 3. This is the answer. Okay. So now let's move on to another concept. There is one concept known as limiting reagent, which we should study now. Now, if any chemical reaction is taking place and we are given the amount of reactants, then from there, limiting reagent tells us how much amount of product is going to be formed. Okay, so it depends on the reactant which is consumed first in a particular reaction. The limiting reagent, as the name suggests, it is the reactant which gets consumed first in a chemical reaction. Okay, so suppose a reaction is taking place, A plus B gives us C plus D. Okay, so here 1 mole of A combines with 1 mole of B, which gives 1 mole of C and 1 mole of B. Now suppose at the start of the reaction we are given with 1 mole of A, 0.75 mole of B, and there will be no C and D at the start of the reaction. But at the end of the reaction, since 1 mole of A combines with 1 mole of B, we can also say that 1 mole of B combines with 1 mole of A. Now since there is only 0.75 mole of B present, therefore 0.75 mole of B will combine with 0.75 mole of A, and 0.25 mole of A will be left in this particular reaction, okay, as reactant. So therefore B is consumed before A, and hence the amount of B determines the amount of product in this particular chemical reaction. So therefore B is known as limiting reagent. Okay, so here at the end of the reaction or after infinite time, this is before and this is after. 0.25 mole of A will be left in the reaction vessel, B will be consumed completely, and 0.75 mole of C will be left, and 0.75 mole of B will be left. Okay, so here the amount of B has decided the amount of C which will be formed at the end of this particular chemical reaction. So B is known as the limiting reagent. So let's see one example here. This is limiting reagent. So suppose our reaction is given to us NaOH plus H2SO4 gives us Na2SO4 plus H2O. Okay, so now let's combine this, let's balance this reaction. So this will be balanced. Okay, so here 2 moles of NaOH combines with 1 mole of H2SO4 to give 1 mole of Na2SO4 and 2 mole of H2O. So here the molecular weight of NaOH is molecular weight of NaOH is 23 plus 16 plus 1 equals 40 km. Or the gram molecular weight is 40. And the molecular weight of H2SO4 is 2 plus 32 plus 4 into 16. This comes out to be 98. Okay? So this is 98 grams. Is the gram molecular weight of H2SO4. Now suppose at the start of this chemical reaction we are given with 60 grams. We are given with 60 grams of NaOH and we are given with 147 grams of H2SO4. Now we have to find out the gram of Na2SO4 which will be formed at the end of this chemical reaction. Okay? So now let's calculate what is the molecular weight of Na2SO4. This is 2 into 22 plus 22 plus 4 into 16. This is 46 plus 96. This will come out to be 142. 142 grams is the molecular weight of Na2SO4. So at the end of this chemical reaction, we have to calculate what is the amount of Na2SO4 that we have obtained. Okay. Now let's see how to solve this problem. So the very first trick is to convert everything in moles. Whatever is given to you, just convert it in moles. Okay. So here, before number of moles present will be 60 by 40, because 1.5 number of moles. And here, the number of moles present will be 147 divided by 98. Okay. So this is equals 1.5 mole. So 1.5 mole of NaOH is present, 1.5 mole of H2SO4 is present before or at the start of this particular chemical reaction. Now, how much amount of Na2SO4 will be formed? So here we can see that 2 moles of NaOH combines with 1 mole of H2SO4. Okay? So therefore, this 2 moles of NaOH combines with 1 mole H2SO4. Now we are given with 1.5 mole of NaOH. So therefore, 1.5 mole of NaOH combines with 0.75 mole H2SO4. Okay. Now we are given with 1.5 mole of NaOH. To combine with 1.5 mole of NaOH, we need only 0.75 mole of H2SO4. So here we have what 1.5 mole of H2SO4. Therefore, H2SO4 is present in excess amount, and hence we can say that here NaOH is the limiting reagent because H2SO4 is present in excess amount. Therefore, this is the limiting reagent. Okay. So finally, at the end of this particular chemical reaction, after the amount of moles of NaOH left will be 0. All NaOH will be consumed because NaOH is the limiting reagent. Okay. Now, in case of H2SO4, only 0.75 moles of it will get consumed. Therefore, 0.75 moles will be left in the reaction. Now, 2 moles of NaOH gives 1 mole of Na2SO4. Now remember here, NaOH is a limiting reagent. Therefore, NaOH will decide the amount of Na2SO4 that will be formed at the end of the reaction. Now here, 2 mole of NaOH gives 1 mole of Na2SO4. So therefore, 1.5 mole of NaOH will give 0.75 mole of Na2SO4. So 0.75 mole of Na2SO4 is formed at the end of the reaction, and 1.5 mole of H2O is formed because 2 mole of NaOH gives 2 mole of H2O. Therefore, 1.5 mole of NaOH will give 1.5 mole of H2O at the end of the reaction. Now, we have seen that the molecular weight of Na2SO4 is 142 grams. So therefore, the weight of Na2SO4 that we will get is weight of Na2SO4. We will get is 0.75 into 142. Okay. So this comes out to be 3 upon 4 into 142. So this is 3 into 71 upon 2. This comes out to be 213 upon 2. Okay. So here, 213 by 2 gram of Na2SO4 is formed at the end of this particular chemical reaction. So, now let's calculate the weight of H2O which is formed. 1.5 mole of H2O is formed in this chemical reaction. So therefore, weight of H2O formed is 1.5 into 18. So this comes out to be 27. So the final weight of species. So final weight of species is final weight. For Na2SO4 is 106.5 gram. For H2O is 27 gram. And no amount of NaOH will be less. And for H2SO4, this will be 3 upon 90 or 147 by 73.5. So 73.5 gram of H2SO4 will be left in the reaction. Okay, so this was the concept of integrating. Now let's discuss some of the basic concepts before going on for volumetric analysis, because that is one of the most important, or in fact, the most important topic in this particular chapter. Okay, so we shall go for volumetric analysis in the next video. In this video, let's discuss some of the very basic questions before going forward. So here, the question one says that calculate the amount of H atoms, or calculate the amount of H, S and O atoms in one 96 gram H2SO, or more precise, let's say it is asking calculate the number of H, S and O atoms in 196 gram H2SO4. Okay, so here Here we know that molecular weight of H2SO4 is 98 gram per mole. Okay. Now given weight is 196. So therefore, number of moles of H2SO4 equals 196 upon 98. This equals 2. So the number of moles is 2 here. Okay. So therefore 196 gram H2SO4 contains, since there are 2 moles of H2SO4, in 1 mole there are 6.02 into 10 raised to the power 23 entities. So therefore 196 gram of H2SO4 contains 2 into 6.022 into 10 raised to the power 23 moles. There are exactly 12.044 into 10 raised to the power 23 in 196 gram of H2SO4. Okay. So now let's go on to calculate the number of hydrogen, sulfur and oxygen atoms in 196 gram of H2SO4. Now since one molecule of H2SO4 contains 1 molecule H2SO4 contains 1 atom. Sorry, it is 2 atoms. So 1 molecule of H2SO4 contains 2 H atoms. Therefore, 12.044 into 10 raised to the power 23 molecules will contain, therefore 196 gram H2SO4 will contain 2 into 12.044 into 10 raised to the power 23 molecules. Okay. Now, with the same argument, since 1 molecule of H2SO4 contains 1 S atom, therefore it contains 12.044 into 10 raised to the power 23 S atom. Here 1 axis H2SO4 contains 2 into 12.044 into 10 raised to the power 23 H atom. Okay. So now, using the same argument, we can conclude that it contains 4 into 12.024 into 10 raised to the power 23 4. Okay. So this is answer here for this particular question. Okay. So now discuss another question, one more question, which involves normality in a very basic form. We shall use it when we'll discuss volumetric analysis in a more advanced manner in the next video. So let's see the very basic application of normality here in volumetric analysis. It is saying that the question says that 20 ml of 2 molar HCl, 20 ml of 2 molar HCl is taken. Then ml of this solution is titrated with ml of this solution is titrated with 20 ml of X molar NaOH, and the titration is complete. Okay, so now titrated with 20 ml X molar NaOH, and the titration is complete. Okay, now Y ml of X molar NaOH is titrated with 5 ml 2 molar H2SO4 solution. Okay, calculate X and Y. This is given in this question. So here, see how many titrations are going on. First, a solution is given to us. Now, some part of this solution is titrated with 20 ml of X molar NaOH. This is the first titration, and the titration is complete. Okay. So now, Y ml of this solution is titrated with 5 ml 2MS2 solution, and the titration is complete. Now we need to calculate the value of X and Y. Okay? So let's see. We know that in case of any titration, the compound, the acids or base, especially in case of acid-base titration, this is known as acid-base titration because we are using an acid and a base for the titration. So in case of acid-base titration, they combine in proportion to the number of equivalents. Now, since we know that number of equivalents equals N into V, therefore, since number of equivalents are going to be equal, this implies N1 V1 equals N2. Okay, so here 20 ml of 2 molar HCl is taken. 10 ml of this solution is titrated with 20 ml of X molar NaOH. So V1 here, let's say 1 corresponds to HCl. Let's say here 1 corresponds to HCl, 2 corresponds to NaOH, and 3 corresponds to H2SO4. So here, normality of HCl is 2 molar. M into N factor. We know that N equals M into N factor. And here the basicity of HCl is 1. Therefore, normality N1 equals. Okay. So here N1 V1 equals N2 V2. So normality equals 2 into V1. V1 is 10 ml. 10 ml equals N2. Since the acidity of NaOH is the same argument, number of ions equals OH negative ions. So the acidity of NaOH is 1. So therefore normality of NaOH will be X into 20 ml, the volume. So here, from here the value of X comes out to be 1. So therefore the solution given is 1 molar NaOH, or the solution titrated with given HCl is 1 molar NaOH. So here, the answer first, X equals 1. Okay, now in case of second titration, when NaOH is titrated with H2SO4, N2V2 equals N2V2. This implies N2. N2 is 1 normal because molarity is 1, and since n factor is 1, therefore normality is also going to be 1. 1 into volume. Y ml of 1 of x is 1, y ml of 1 molar NaOH. Now let's write y in case of volume. So 1 into y equals 5 ml. 5 is the volume, and 2 molar H2SO4 solution. 2 molar H2SO4 solution. So here in this case, n of H2SO4 will be 2 into n factor. N factor is 2 because here in case of H2SO4 the number of ionizable H plus ions are 2. So n of H2SO4 equals 4. So here this will be 4 into 5 molar, 5 milliliter of H2SO4. So from here we get y equals 20 milliliter. This is the This was an example of volumetric analysis of titration, the acidic titration. We shall hope you have got the concept here. In this example, we shall discuss volumetric analysis in great detail in the next week. That's all.